Statistics for ship hulls show that 90% of ship failures are attributed to corrosion. Corrosion, or rust, is a common sight on seagoing vessels. Year upon year, the cost of marine corrosion has increased until it is estimated today at 4% of the gross product. To repair the coatings offshore, it can be up to 100 times the cost of initial coating. Estimation of 50 to 80 billion dollars every year. Wow, it involves a lot of money, but just for repairing, imagine that. I have friends working as marine engineers, and I asked them, what did you do to prevent this corrosion? Well, they introduced me to this anti-fouling marine paint. So I did some study and found out that this anti-fouling coating does not last long. They age, weaken, and deteriorate. It is also said to be harmful to the marine life because of the toxic contains in it. Studies have shown that these compounds persist in the water, killing sea life and possibly entering the food chain. And since 2008, this anti-fouling system is prohibited or controlled by the IMO, International Maritime Organization. In this blooming world of technology, nanotech has become very famous and continue to develop in shaping the future. One of the applications is nanocoating. Nanocoating is a thin films that apply to surfaces and layers to achieve vast range of functionalities. In example, for corrosion protection, friction reduction, anti-icing, anti-fouling, self-cleaning, and many more. Talking about corrosion protection, there are many ways to protect a surface from corrosion. To reduce the loss of metal materials due to corrosion, building a protective film on the metal surface is one of the most useful and effective ways to overcome this problem. Therefore, in my research, I will improvise the nanocoating to a super hydrophobic coating on a metal substrate and suitable for marine application. So what is this super hydrophobic? Imagine you have a lotus leaf and you pour water to it, but the water does not stick to the lotus leaf. Instead, it repels. So this is the example of what a superhydrophobic is. So I will prepare a solution of nanoparticle and metal oxide, in this case zinc oxide, and a polymer base which is an epoxy in a container. Stir it and then apply it directly onto the metal substrate. There will be a variety of techniques to apply the coatings, such as spray, paints, etc. Then, to make sure it's compatible with the seawater, I will do a corrosion test where the metal will immerse in the sodium chloride solution and measured by the salt spray testing chambers. And lastly, to analyze the surface of this nanocoating, we will use XRD and SEM. This process looks very simple, but I highly believe that it will solve the big problem of corrosion in marine applications. Thus, it reduces the maintenance cost. This nanocoating will be an ideal and effective coating that is needed in the marine industry. Most importantly, it will not harm the marine life. Hence, this complies to the National Policy on Biological Diversity 2016 to 2025. Not only we can solve corrosion problems, but we can also save the marine biodiversity. Combat corrosion, save the ocean. That's all from me. Thank you.